All right, number 13. We have a 70-kilogram base runner. He's a baseball player. I can't draw a baseball player to save my life, so it's a box. We have a box. The mass is 70 kilograms. So here's the base runner. The base runner starts his slide. He's with an initial velocity of 4 meters per second. That's a given. Slide, slide, slide. We're told that the coefficient of friction between him and the earth is 0.7, and he slides so that his speed is 0 just as he reaches the base. So velocity final is 0. So the first question, how much mechanical energy, so what do they mean by mechanical energy? Mechanical energy is what? Kinetic plus potential. Kinetic plus potential. How much mechanical energy is lost due to friction acting on the runner? Okay, so let's figure that out first. So let's take his initial information. So we have kinetic initial, potential of gravity initial, and then just to be complete, we'll mention potential of spring, because spring, energy in a spring is also mechanical energy. All right, then over here, final, we have kinetic final, potential of gravity final, and potential of spring final. So let's just fill these in. Does the guy start with any spring energy? Is there a spring in this problem? No, that'd be kind of weird if a base runner had some sort of spring. Nope, zero joules. All right, potential of gravity. Look, this whole problem is taking place on the same horizontal position, right? Is there any hill here? No. So where's the 0 point for this problem? The 0 point is the ground itself, right? So what can we say about potential of gravity initial? It's 0. How about potential of gravity final? Also 0. Does that make sense? The only time you're going to get a change of potential energy is if there's some sort of vertical climb or vertical drop. Okay, so there's no potential of gravity here. Now, kinetic initial. Does this guy start with kinetic? Yeah, because he's moving. So you go 1/2 mv squared. This comes out as 560 joules. All right, what's his kinetic final? 0, right? Because he stops. Any spring energy final? No. So guys, how much mechanical energy does this guy end with? What's the mechanical final? 0. How much mechanical energy did he start with? Mechanical initial is 560. So what's the answer to the question? How much mechanical energy did friction take? All of it. All 560. Okay? All 560. So the answer to A is 560 joules. B, how far does he slide? Now look, you could solve this using forces only. You know, like sum the forces, find acceleration, do a kinematic. But how would you do this chapter 5 style? Well, let me show you. So to do this chapter 5 style, we're going to use this idea, net work always equals change of kinetic. Okay? Now guys, in this problem here, what is the only force doing work as the guy slides to rest? There's only one force that does work, and what is that force? Friction. So what is the net work? If there's only one force doing work, then the net work is the work done by that force. So the work net will be the work done by friction, right? And the work done by friction is going to be negative. Why negative? Because it's opposite motion. Okay? What's kinetic final? 0, because he stops. So we have negative work of friction equals negative kinetic initial. Does that make sense? Okay. Well, so the negatives cancel. The negatives drop out. So what is our basic work equation? The basic work equation is what? Force times displacement. Hold on. Now kinetic initial was 560. So look, we're almost done here. So the delta x is going to be 560 over friction. But what's the friction equation? Friction is what? mu times normal force. What's the normal force? If you look at this box here, we have normal force up and mg down. What is the normal force? It's mg, right? So you plug into this and you get 1.17 meters.